Okay, so in this video, we're going to take a look at a new angle now on complex numbers and introduce the Argand plane. So we are used to a traditional number line, okay? So back all the way since you were very, very young, you have known the number line, right? And originally, maybe you knew the positive numbers back in grade 2. And that went on forever. And then maybe at some point, grade 4, grade 5, you were introduced to the negative numbers. There you go. And now it's time to learn the hard truth, and that is that actually it's not a line at all, it's a plane, okay? You've just been thinking about one small component to it, right? The real numbers. And the real numbers lie on the real axis, which is the number line you know and love. But there's more to it than that. It turns out it's not a line at all, it's a plane. And actually, we have another axis, right? And that is the imaginary axes. There we go, okay? So if we have an imaginary axis, we are able to mark on our new plane, the Argand plane, all right, complex numbers, all right? We'll take a look today at why and how that works. We're going to use vectors, although you do not need a background in vectors to understand this today, okay? Just to help us illustrate some points. So what can we say? Here are some statements of truth. All real numbers with b equal to 0 lie on the real axes, right? Okay, so that really is saying that when the complex component, the imaginary part of it is 0, we're on that real axis, okay? So 7 plus 0i really is just 7. It's on that axis at 7, okay, on the x-axis like you know and love. But what this is suggesting is that real numbers that you're used to, well, they're just a subset of complex numbers. That's a small amount of complex numbers that are on that line, but there's a big world out there full of complex numbers. The real numbers are just a small part of it, right? And of course, if they're purely imaginary, well, that means there's no real component, right? So something like 4i really is 0 plus 4i. Well, that number would appear on this plane, on that kind of what we consider the y-axis or the imaginary axis now, okay? That's going to be on there. Right, and if they're not purely real or not purely imaginary, well, they'll be in one of the 4 quadrants, okay, that we expect to see in all our diagrams. Okay, so let's just jump in then and take a look at some examples of how this might work. So here is a nice picture of the Argand plane, and we've got some lines in it, right? Now, I'm going to use vectors because it's kind of standard practice to do so, but it's nothing to worry about. P, the point P, look there at 2, 3 on that diagram, we'll just say is like the vector O to P, and we denote that with an O and a P and an arrow going from one to the other, because O is that 0, 0 point, and that line, look, is the O to P. So O to P kind of corresponds to the position vector of P, which can be written as 2 plus 3i, okay, in the Argand plane. So that point P there, look, or the vector OP, corresponds to a particular complex number, 2 plus 3i. What about Q? Well, O to Q is going to be 4 minus I, right? The real component, the 4, because it is here, look, on the real axis, and minus 1 on the imaginary axis. So that's where these 2 particular parts are coming from. Okay, let's move on. Well, what about O to R? Well, you can see R there, look at 0 minus 3. Well, that is just going to be minus 3i. There's no real part to that because we are on that y-axis, right? On that imaginary axis. And then finally, O to S. Well, that's going to correspond to the complex number minus 3 minus I. Okay, well, what about the other way around? Can we illustrate particular complex numbers on this Argand plane? Yes, we can. So first of all, we're going to need to start with an axis. Let's zoom in a bit and see if we can make this a bit more accurate. And we'll say one of those squares is going to be just one integer. Okay, and I won't do the markings. We'll save some time. Hopefully you get the idea. Right, so what about the first one then? So let's take a look. Z1 is just the number 3. Well, the number 3, okay, let's write it there, look. It's just that, isn't it? Right, okay, if I was going to draw those arrows in again, I might write it like that. Okay, but that is representing that value there, look, of 3. What about Z2? So we've got 4 in the real direction. Let's make a note and make sure we write that real direction, look, and that imaginary direction. Okay, so this one has a real component that is 4 and an imaginary component that is 3. So we'll need to be a 4 across and 3 up. Z2 is going to end up there. Let's draw that arrow in, look. So Z2, perfect. Let's carry on. What about Z3? 5i. Well, this has no real component, so we're at 0 on that real axis. We're at 5, though, on that imaginary axis. So let's draw the arrow in again. That arrow there, Z3. Z4, well, we've got a -4 and a positive 2i. So -4 in the real direction, 2 up in that imaginary direction. If I was drawing the line, that would be the arrow, look, that represents the complex number Z4. Z5 is -3 minus I, so we're going to be there. Z5. And then Z6 is just a -2i. Well, that's going to be there, isn't it? Look, Z6. Okay, so hopefully this video has given you an understanding of the Argand plane and just made sure you understand how we can label particular vectors as complex numbers.